I'm going to be trying to create a sinusoidal wave equation for the data given for Cleveland from the years 1961 to 1990. I'm going to be looking at the mean temperatures for those years, and I have all my years listed here, or all my months listed here. And I'm going to go ahead and plot these by hand, and when I plot them by hand, I'm going to list everything twice so you can actually see the sinusoidal wave. So for January 1, 2, 3, 4, I'm going to count my months by ones. And then when I get to January of the second year, it's going to be 13, 14, 15, 16, and so forth. I'm going to have the regular temperatures for month 1, and then also for month 13 it'll be the same temperature. When I do that, I end up with a graph that looks an awful lot like a sine wave, which is what we want it to look like. This is month 1. This is January 1 of my first year, and then down here is January 1 of my second year, and then again of my third year. So you can see where I graphed 2 years. What you also need to notice is that, remember that when we do a vertical shift, we want to make it so that our vertical shift is halfway between our max and our min. So we want our vertical shift to be the average between our max and our min. And just looking at it kind of carefully here, you can see where maybe just a little bit less than 50 degrees is going to be our vertical shift line. And then our amplitude is going to be from that vertical shift line up or from that vertical shift line down. So now I'm going to go ahead and put these same values that we had before. I'm going to put them on my calculator. When I go to put them on my calculator, and I hope you guys can all see the calculator here. Let me try to zoom out a little bit so you can see the whole calculator. You got a good portion of it. There we go. So when I go to use my calculator to enter these values, the first thing I need to do is I need to go to my statistics plotting system here, and that's this button right here where it says STAT. So I'm going to push my calculator on. I'm going to push STAT, and you're going to see this come up. And I'm going to go ahead and edit my lists, and I'm going to be putting numbers in list 1 and list 2. If you already have numbers, in this case I have numbers already in list 1, and I want to remove them, I don't want to use those particular numbers, all I need to do is go up and highlight L1, press clear, and then press enter. And you'll notice that all your values disappear. So if you already have something in list 1 and list 2, that's how you can get rid of them. Now we're going to go ahead and put numbers into list 1. We're going to start off with January's being month 1, and we're going to go up to December, which will be month 12. And then we're going to start all over again, with January being month 13th and December of the second year being 24. So in list 1, you want to put 1 through 24. In list 2, we're going to put the temperatures that correspond to each of these months, and we're going to be listing them twice. Okay, now that I have all the values in my calculator, the next thing I'm going to do is I'm going to go to my window and have a proper window. Remember, your X values are your months, and they go from 1 to 24. So in the X direction, I'm going to have my values be from a minimum X value of 0, and I'm going to go to a maximum X value of 25. So under my window, my minimum X value is going to be 0, my maximum is going to be 25, and that's okay if I have it on a scale of 1. Next thing I'm going to do is go back and look at my stat plot, or actually looking at these values right here. What is the minimum value, minimum temperature mean that I have? And that would be my 24.8. So this is my lowest one. And then where do I have my highest temperature listed? Well, that would be in July with 71.9. So that means that in the Y direction, when I'm trying to figure out my scale, I can start as low as maybe 24. So my Y minimum would be 24, and my Y maximum should be at least 72. I'm going to make it 75 just to make sure I'm on the upper side of that. And in the scale, I don't want to have 50 dashes in the Y direction. If I make each one worth 1, I'll have 50 of them. So I'm going to make each of them worth maybe, I don't know, 5. So each slash mark will be equal to 5. Then I'm going to go to my Y equals button. And I notice that I already have some things in here, so I'm going to go ahead and delete those out. And then I'm going to arrow up to my plot 1, and I'm going to press enter. So now plot 1 is highlighted, and I should be able to graph. And there we have the graph. And it looks very similar to the one that I did by hand. So putting these two graphs together, you can see where they're very similar. Obviously on the screen it's going to be a little bit more compressed than it does on the paper. So now my goal is to find an equation so that when I go to graph the equation with the stat plot, that it matches pretty darn closely. So now I'm going to go ahead and try to figure out my equation. We're trying to come up with an equation now, use the information that we have here, and the first thing we're going to do is we're going to look for our vertical shift. And our vertical shift, remember when we were looking at the graph, was halfway between our maximum and our minimum. So our vertical shift, which is our B, is equal to the average of your maximum and minimum values. And I forgot to put here at the top, remember we're trying to come up with an equation that's of the form S of t equals A sine parenthesis omega t plus phi plus B. So right now we're finding our B, and our minimum value is 24.8 and our maximum value was 71.9. And to find the average of those two, I'm going to add them together and divide them by 2. And my average ends up being 48.35. So that's going to be my B value now when I go ahead to write into my equation 48.35. And remember when we were looking at the graph before that we said it looked very much like right around 50 would be where my vertical shift is at. And 48.35 is pretty darn close. Okay, next thing we're going to do is find our amplitude, and that's our A. And remember that our amplitude is the distance between our maximum value minus our vertical shift, or our vertical shift minus our minimum value. Either way, you should get the same answer. So if we take our maximum value of 71.9 and we subtract our vertical shift of 48.35, we should get the same thing if we take our 48.35 and subtract our minimum value of 24.8. Now you only need to do one of these expressions. You don't need to do them both. I'm just trying to show you that either one will give the same answer. And when I do these with A is equal to 23.55. So now looking at my equation, I know my B, I knew my A, I need to find a few more things. And remember, this is a sinusoidal function in relationship to t, so we're not going to find the t value, but we need to find our omega and our phi. Well, remember your omega is determined by your period. So your period is t, and that's equal to 2 pi over your omega. Well, my period for this particular function is 12 months. So 12 equals 2 pi over omega. I'm going to multiply both sides of the equation by omega. I end up with 12 omega equals 2 pi. And then I'm going to divide both sides by 12. And when I do that, I end up with omega is equal to 2 pi over 12, which reduces to pi over 6. So now I know my omega, and I need to figure out my phi. And your phi is your horizontal phase shift, or your horizontal shift. So what we do there is, remember, we're going to go back and look at our graph. And looking at our graph, remember when we have our vertical shift, that's where our new sine graph is going to start. And remember, our sine graph goes up to the max, down to 0, back down to the minimum, back up to 0. So I want to figure out where my vertical shift is, and it's at 48.35. So 48.35 is just shy of the 50. And I want to find a point that's going to be where I'm going to start my sine function. So can you see where this point right here, which corresponds to April, is darn close to the 48.35 that we're hoping to have. So if I look back on my chart here, 47.6 is real close to that vertical shift of 48.35. So we're just going to go ahead and first we're going to try what if t is equal to 4, as in for April. So we're finding phi by letting t equal 4. And we're going to say that when t is equal to 4, that my s of 4 is going to be equal to that vertical shift, 48.35. So my temperature in April, I'm going to say is my vertical shift, even though we know it isn't. But that gives me a good starting point. So I'm going to go ahead, use this equation up here. I'm going to put in 48.35 for my s of t, and I'm going to put in 4 for t, and the only thing I'm not going to know is my phi. So I'm going to go ahead and do that. So I have 48.35 equals my a, and remember, maybe I should go ahead and box these in so we can find them. This is my a, here's my b, and here's my omega. So I have 48.35 equals a, which is 23.55, sine pi over 6, and we're using t equal to 4, times 4, plus phi, plus my vertical shift, which is 48.35. I'm going to go ahead and subtract the 48.35 from both sides. When I do that, I end up with 0 is equal to 23.55. And then I'm going to go ahead and multiply pi over 6 times 4, which gives me 2 pi over 3 plus phi. Then I need to figure out where, I'm going to divide both sides first of all, by 23.55. And I end up with 0 equals the sine of 2 pi over 3 plus phi. So now my question is, the sine of what angle gives me a value of 0? So where on my unit circle is sine equal to 0? Well, it's equal to 0 at 0 and pi. Well, we're going to use 0. That's the easiest. So remember that the sine of 0 is 0. And I'm going to say, okay, then let's take what's inside of these parentheses, 2 pi over 3 plus phi, and say that's equal to 0. If this is 0, sine of 0 is 0. And then I solve this for phi, and I end up with phi is equal to 2 pi over 3. So now I can come up with my sinusoidal, at least a beginning sinusoidal wave, and that is that s of t is equal to a, and remember a is 23.55, sine omega, which is pi over 6, t, minus 2 pi over 3, plus my vertical shift, which is 48.35. So now I'm going to put this into my calculator under my y equals button, and I'm going to graph it along with the stat plot that I had graphed before. So under my y equals button, I'm going to put in 23.55 sine, and then where I have pi 6t, I'm going to put that into my calculator as pi x divided by 6. And here's your x coordinate, or your variable. Once I have that entered in my calculator, I'm going to go ahead and see how it looks along with the stat plot that I had. So I'm going to go ahead and graph this. And look at what happened. So when I see a horizontal line going across like this, that tells me that my mode is probably wrong on my calculator because it's not graphing the way I want it to. So underneath the mode button, I should be in radians. And looky, I'm in degrees. So we need to switch this to radians. And now I'm going to go ahead and graph again. And that's a pretty darn close sinusoidal wave for this particular problem. I could try to get the right side of the wave over to the right a little bit more, but then the left side's probably going to be off a little bit. So when you're doing problems like this value right here might need to be changed a little bit. To change it, I'll show you how to do that. But in this case, this is a pretty darn good looking graph for the plot that we have. If I want to try to tweak it a little bit, this is what I'm going to do. So remember when we were finding phi before, we used t was equal to 4. And that was corresponding to April, which was 47.6 degrees. Well, my vertical shift is at 48.35. So I'm probably going to want it to be a little bit more than just the beginning of April. So now I'm going to say, well, what if we let t, instead of being equal to 4, let's say, what if it's equal to 4.2? And then we're going to say again, S of 4.2 is equal to our vertical shift, which is 48.35. And we go through all the algebra again by taking our equation, 48.35, setting it equal to my amplitude, 23.55, sine omega, which is pi over 6, times 4.2 over 1, plus phi, plus 48.35. And solving the whole problem again like we did before, and then dividing by 23.55 on both sides, I end up with 0 equals sine 4.2 pi over 6 plus phi. And I ask the same questions. Where is sine equal to 0? It's at 0 radians, so I'm going to take 4.2 pi over 6 plus phi, set it equal to 0, solve for phi, and phi in this case is going to be equal to negative 4.2 pi over 6. So now I'm going to put this particular equation into my calculator. S of t is equal to my amplitude, 23.55, sine, and now I'm going to put in pi over 6 is my omega, t, minus, and here's my phi, 4.2 pi over 6 plus 48.35. So the only thing that's changed in this equation is this number right here. Everything else has stayed the same. So I'm going to go back to my y equals button. And everything stays the same except for instead of having 2 pi over 3, I'm going to have 4.2 pi. So to be able to put that in there, I'm going to press second and I'm going to go delete, which if you see in yellow it says insert on my particular calculator. So second, insert, and I'm going to put in 4 point, and I've already got the 2 in there, and then I'm going to come over here and I need to put a 6 in the denominator. And then everything else stays the same. I'm going to go ahead and graph. And that does look a little bit better. It seems to be going through my points a little bit nicer. So this particular equation is probably better, and as you can see, you can continue to tweak it by changing your phi value. So maybe you want to try 4.3 pi over 6 and see if you can get this curve to be even closer than it actually is. But that's a pretty darn looking good curve.